Folks, welcome to my YouTube channel. Today we're doing the acids and bases. It's Mpumalanga September 2024 question paper. I'm gonna specifically focus on acids and bases. 7.1, it says hydrogen carbonate ion. That one can act as an ampholyte, right? Now it says explain what is meant by the underline word. So by the underline word, it means a substance can act as either acid or a base. So it can be an acid, it can be a base. 7.2, it says consider the following reaction. We have a hydrogen carbonate ion reacts with water and give us the carbonate ion and hydronium ion. Now the question, it says, is the hydrogen carbonate ion in this reaction acting as a Bronsted-Lowry acid or Bronsted-Lowry base? If you check that, here it's a hydrogen carbonate ion. Now it's a carbonate ion. That means it has lost a proton there. So if it has lost a proton there, that means it has donated a proton. That means it acts as a what? As an acid. So the answer here is what? Is acid. It's a Bronsted-Lowry acid. Now the answer for that, you can say, it says give reason for your answer. You can say it produce the hydronium ion. It produces hydronium ion when dissolved in water. When dissolved in water. Or you can say it donates proton, right? Because it acts as an acid, it donates a proton. 7.1.3, it says write down the formula of the substance which form a conjugate acid base pair with the hydrogen carbonate ion. So the acid base pair, it's these two. The acid base pair, they differ by the hydrogen ion. So the answer there, it's the carbonate ion. That's the formula, right? 7.2, it says two identical electrolytic cells are set up as follows to determine the conductivity of sulfuric acid and the carbonic acid. So this conductivity that is to be determined here is the electrical conductivity. Do you see the electrolytic cells? Now it says the concentration of both solution is 0.1. So they have same concentration and it's different acids there. But you need to understand, one thing that you need to understand that is very important is the strength of the acids. The strength of the acid in terms of conductivity, it's very important. Sulfuric acid is a strong acid and the hydrogen carbonate is a weak acid. So the strong acid has a high conductivity. So this one has a what? High conductivity. And the hydrogen carbonate, since it's a weak acid, it has a low conductivity, which is which conductivity? Electrical conductivity, right? Now it says which diagram's bulb will burn the brightest? Give reason for your answer. Which one will burn the brightest? It says I must give reason for answer by referring to acid. So the one that will burn brightest is the one with the strong acid, because it produces the high concentration of hydronium ion. It's very important to say it that way. It produces the high concentration of hydronium ion. So so the answer here, it will be A. And the reason for that, you will say sulfuric acid ionizes completely in water to form or to produce high concentration of hydronium ions, right? The form concentration of hydronium ion, very important. Now 7.3, it says the concentration of sulfuric acid In the solution, it's 0.25 times 10 to the power negative 3 mole per dm3. It says calculate the pH. Guys, it's very important. In 7.3, to calculate the pH, you must change the concentration of sulfuric acid into the concentration of what? Hydronium ion in order to get the pH. You calculate the pH by the concentration of hydronium. So what are we going to do now? I'm going to the concentration of hydronium ion is equal to 2 times the concentration of what? Of sulfuric acid, because the sulfuric acid is the diprotic. So the concentration of hydronium is 2 times the concentration of sulfuric acid, since it's a diprotic. So we're going to say 2 times 0.25 times 10 to the power negative 3. The answer there, it will be 0.5 mole. No, it's 0.5 times 10 to the power negative 3 mole per dm3, right? So that's the answer there. Now, in order to get the pH now, you have now, you are in this step now. You can calculate the pH. You write the formula of the pH. pH is equal to negative log concentration of hydronium ion, and then you say negative log times the concentration of hydronium ion, which is at 0.5 times 10 to the power negative 3, and then the answer there, it will be 3,3. And it makes sense. The concentration of sulfuric acid, it needs to be in that range because it's a strong acid, right? 7.4, it says a sodium carbonate is a salt that forms when sodium hydroxide reacts with the hydrogen carbonate, the carbonic acid, and this salt reacts with water. Now it says write down one word for the underlined part. So the salt that reacts with water, we call it, it's a what? Hydrolysis, right? It's the hydrolysis. And then 7.4.2, it says, is the aqueous solution of sodium carbonate acidic or basic or neutral? Guys, you look what is between these two. This salt, which is this sodium carbonate, it comes from a strong base and a weak acid. So what is strong between the two is the base. So this is going to be basic, right? It's going to be basic. Now 7.5, I already made some preparation so that I can save time in this question. Now in this question, guys, it's very important. It's an 8-mark question. Guys, you need to attempt such questions. Don't be scared with these questions. Now it says here, a standard solution was prepared by adding an unknown amount of sodium, barium hydroxide to a 250. So here's the standard solution, guys. Here there's a barium hydroxide. Barium hydroxide is a strong base, and then it was diluted with water here, and then it fill this conical flask. This flask, and it fills to the brim and with water by 250. That's the standard solution. But it says a standard solution was prepared by adding an unknown amount of barium hydroxide. We don't know the amount, which is the mass that was added here to make this standard solution to be 250. So this is a standard solution where we do not know its mass and we cannot know the concentration of that. Now it says the barium hydroxide now reacts with the hydrochloric acid according to the following. Here's the barium hydroxide reaction with the hydrochloric acid. It gives you barium chloride and water, right? So they react the two. Now it says 25 cubic centimeter of the standard solution, which is the barium hydroxide, reacts with 100 of the diluted hydrochloric acid, which has a concentration of 0.5. So guys, here I want to show you We take the 25 out of the standard solution. There is it. It reacts with what? With the HCl, as we are told here. It reacts with the HCl, which is the 100 cubic centimeter with the concentration of the HCl. Here are both of them here, right? And then we take in this unknown standard solution with an unknown amount, which is the mass, and then the concentration we react with the acid there. We make another solution, right? Now it says here sorry, the excess of barium hydroxide is neutralized by adding 50 cubic centimeter of 0.05 mole per dm3 of sulfuric acid. Okay, what this means if this, they say it is an excess, that means there will be an amount, it's not going to be used up completely. The barium hydroxide is not going to be used up completely. That means the HCl, the one that is reacting with, is the limiting. That means it's going to be used up completely. So these amounts of the HCl, this amount of the amount available of the HCl will react completely with the excess, with the barium hydroxide, right? Now it says here the excess of the barium hydroxide is neutralized by adding 50 of 0.05 of sulfuric acid. All right, so when these two react, there will be an excess in the barium hydroxide. So that amount of barium hydroxide that remained is taken to react with the sulfuric acid, which is with the 50 cubic centimeter and 0.05 of the sulfuric acid there, right? And we do not know still the concentration of this, right? But what we know, it's an excess that is taken there. It's what remained there, and we do not know even the amount that remained there that we added to the sulfuric acid with those concentration. So here's the reaction for that. The reaction of the barium hydroxide and the sulfuric acid, which is this barium hydroxide, it's an excess. It's what remained here. It's the remainder. When these two reacted, the HCl and the barium hydroxide, the remainder we've taken to that beaker and we react with that. Now, the question, it says calculate the initial mass of barium hydroxide used to prepare the standard solution. So in this process, we want what was the amount that was added here, and it was filled with water to a calibrated mark of 250. We wanted the mass that was added here when we were preparing the standard solution. So in order to do that, we're going to start backwards. So what is going to help us here, we first need to get the amount. We have to start here to get the amount of the sulfuric acid that reacted with the excess there. So we're going to do that and calculate that amount, right? So we're going to say, I'm going to write it step by step, guys. Just I'll say the amount of sulfuric acid reacted with excess. So we're going to calculate the number of moles of the sulfuric acid that reacted with the excess. So this is the excess. So this is what remained here. So we'll calculate the number of moles of this so that we can get how much was an excess there. So that's what we're going to do. So we have a concentration in the volume. We will say the number of moles of sulfuric acid is equal to CV, and the concentration is 0.15. We times by the volume, it's 50. We divide by 1000. It's going to be 0.05, and then the answer there is going to be 0.025 mole. So this is the amount. This is the number of moles of the sulfuric acid reacted. Now, in order for us to know the amount, which is the excess that reacted with this one, we have to do the mole ratio. So from the balance equation, the sulfuric acid reacted with the barium hydroxide, and the mole ratio, it was 1:1. So we're going to say barium hydroxide reacted, which is it's the excess. This is the amount. This is the amount of barium hydroxide, which is the excess reacted with the sulfuric acid. So now what I'm doing now in this step, I'm calculating, I'm gonna do the mole ratio now that I know the amount of the sulfuric acid that reacted with the barium hydroxide. Is gonna help me to get this excess by doing the mole ratio. The ratio is 1:1. So I'm gonna say the number of moles of barium hydroxide, which is it's the excess, is equal to the number of moles of sulfuric acid, because the mole ratio is 1:1. So it's this amount, it's 0.0025 mole. Now I have this amount. Now I have the excess. Now I have the excess. Now I'm gonna go back. Now having that excess, I'm gonna go back and calculate the amount. I'm going to calculate the amount of this. Remember, this HCl, it was a limiting, it was used up. So this whole amount of the HCl, it was used up. So now I'm going to calculate this amount so that it can help me to get the amount that reacted there. And now I know with this amount that reacted, I know what is left is this amount, which is this amount that I just calculated now. So now I'm going here now in this. I'm going to calculate the amount of the amount of diluted HCl reacted with barium hydroxide. So here I'm here to calculate this amount so that I can get the amount of barium hydroxide reacted there. So what do I have there? I have a concentration and the volume. So I'm gonna say number of moles of HCl is equal to CV. The concentration there, it's 0.15, right? No, the concentration there, it's not 0.15. The concentration, let me double check, it's 0.1 and 100. 0.1 and 100. Let me double check. The HCl, it's 100, it's 0.15. Here it's supposed to be 0.15, guys. It's 0.15. So it's gonna be 0.15 times 0.1, which is the volume. The 100 when you divide it by 1000. The 100 when you divide it by this 100, when you divide by 1000, it's going to be that, and the answer there, it's going to be 0.015 mole, right? So now guys, we have the amount, this amount, the limiting, the amount that was used up here. It can help us to get this amount of the barium hydroxide reacted, right? So now the next thing, now we're gonna do the mole ratio again. Now I'm going to calculate what? Now I'm calculating the amount of what? Barium hydroxide reacted with HCl. So now I'm going to calculate this amount here. The barium hydroxide reacted with this HCl. I'm going to do the mole ratio of the HCl and the barium hydroxide. So here's the ratio is 1:2, right? So I'm going to say the number of moles of barium hydroxide is equal to half times the number of moles of the HCl. Because of the ratio, guys, is 1:2, so it's going to be half. So I'm going to say half times by this amount, which is 0.015, and then the answer, it will be 0.0075 mole. So now I calculated this amount. Now I have this amount, which is the amount that reacted with the HCl. So now what I can do now, having that amount, I can get the initial number of moles. Now I can get the initial number of moles because I can get the initial number of moles here, because what I can do now, I can take the excess and what reacted, it makes the whole amount that came here. So this was the full amount. Now this full amount, we do not know how much was it. Now we know, so I can say now, I can say this amount that reacted and the excess, it can give us the full amount, which is this amount that was here, that was taken here. I'm not sure if I make sense. Let me write it so that we can see. Now let's say initial amount of barium hydroxide, initial amount of barium hydroxide. What I'm going to do, I'm going to say the initial amount of barium hydroxide is equal to the number of moles of an excess, right? It's number of moles excess of the barium hydroxide with the excess reacted with, let's say reacted with the sulfuric acid, plus, okay, let me put it back here, and the number of moles, come on, plus the number of moles of the barium hydroxide reacted with HCl. So now guys, this amount now, the number of moles of excess reacted with the sulfuric acid, it's gonna be this one, this excess here. I'm gonna add this excess with the barium hydroxide reacted with the HCl, and it will give me the initial amount. So I have those amounts here. So these amounts, it's gonna be the one that reacted with the HCl. The excess is this one, so we're gonna take this amount to here. So it's 0.0025 plus, and this amount, the one that reacted with the HCl, which is a 0.0075, which is the answer. It's gonna be 0.01 mole. Now we have this number of moles is the number of moles which is the initial, right? The initial, which is the initial number of moles, the one that was taken here, right? So what are we going to do now? We're going to calculate this number of moles in terms of the 25, because this number of moles, it was that was taken from here, its volume, it was 25 cubic centimeter. So I'm going to use this volume and the number of moles of the initial and get the concentration of this, right? And get the concentration. So what I'm going to do, guys, this is quite lengthy. I will say the initial amount again of barium hydroxide in 25 cubic centimeter, so that we can get the concentration, because what was taken here, it was a 25. We want to know its concentration. It was a 25 cubic centimeter, so we wanted the concentration now. So I'm going to calculate the concentration of barium hydroxide is equal to Cn over V, which is the number of moles is this one. So it's going to be 0.01 divided by the volume. The volume is 25. The 25, when you divide it by 1000, it's going to be 0.025, and then your answer is going to be 0.4 mole per dm3, right? So this is the concentration. This concentration, it's a concentration that was taken here, right, with this volume. Now the question wanted the mass, the initial mass. So remember, the initial mass, it was in 250. So we have to calculate, we have to change that concentration, this concentration in terms of what? 250 now. in terms of 250 mole per dm3. So we're going to say now initial, again it's still an initial amount of what? Of barium hydroxide in 250. Now we're calculating it in the standard solution. Now what was it? So we'll say C is equal to mass over molar mass times volume. Why are we using this formula specifically? We have the concentration, we have the molar mass of the barium hydroxide, we have the volume, which is the 250. So the molar mass of the barium hydroxide is equal to 171 grams per mole. Guys, you can calculate that. So the mass, the initial mass is the one that we want. We will say 171 times the 250, which is, it's gonna be 0.25, and then the concentration is this one. We substitute, it's 0.4, and then you do your math. And the mass, which is the initial mass, now the final, the mass of barium hydroxide is equal to 17.1 grams. So this standard solution, when it was prepared, it was 17.1 gram that was added here in mass in a solid, and then distilled water was added there, and it was filled to the brim to make the what? The 250 solution. In this 250 solution, the 25 cubic centimeter, it was reacted with the HCl there. So when these two reacted, this one, there was an amount that remained, which is an excess. This amount that is excess was added to the sulfuric acid. So we started by calculating this amount that was remaining here. We calculated it, and then we went here and we calculated this amount that reacted here, and then we added the two amount that gave us the initial, and we calculated in terms of the 25 and then in terms of the 250, and then it gives us the initial. I hope, guys, that makes sense. Cheers. Bye.